So the gradient will be 0, right? So in this case, using the derivative, okay, we now know that dy over dx is going to be equal to 0. Then we will work backwards to find out what is the value of x, and then after that we will be able to get the y coordinate as well. You understand what I'm saying? So this is a reverse process. Earlier on, we are trying to find out what is the gradient. So we take the x, we substitute into derivative. Okay? Whereas in this case, we are told what is the gradient. We need to find out what is the coordinates. So we work in reverse. Okay, substitute in dy over dx equals to 0. And then we solve, okay, for the value of x. Okay, so in this case, x squared is equals to half. So what will x equals to be? X equals to
1 quarter.
1 quarter.
1 over 1, 2 square root. 1 over square root.
1 over square root 2, is this the only answer?
Plus minus.
Plus minus, Okay, remember when you take square root, you need to consider both positive and negative. Okay? And so now that we have two coordinates, okay, for x, so when x is equals to 1 over square root 2, we will find out what is the value of y. Okay. In A-maths, you try to leave your answer in exact cert form. Right? You need not rationalize the certs. Okay, this will be good enough. Unless, of course, if the question asks you to rationalize the certs. Yep. Sorry? Wait, 1 over square root 2. Where is it wrong?
The textbook says the answer is only negative 2 divided by square root.
But it's a textbook that's wrong.
Wait, actually my book also says the same. Where did I do wrong? Negative 2, 1 over square root 2 minus, okay. Oh, actually it's just a lack of simplification. Textbook says this, right? Negative 2 square root 2, is it? Right? So it's just a lack of simplification.
This one.
Yep.
You leave it in the white house.
Do you have to simplify?
Let's do our best in simplifying.
The best is my
You tell me I don't get it.
so you cannot laugh.
Huh?
You do square root 2.
Square root 2 times square root 2 over square root 2 ma. This one.
Wait, what?
Spoon already.
Then so why the thing
Yeah.
draw down then they got super?
Sorry, this one.
Yeah. What?
Because I times this with square root 2 over square root 2. So this is square root 2 over 1. So square root 2 times square root 2 gives you 2. Then now the denominator is square root 2. Can I go back and check about the simplification again? Okay. Whether is it acceptable? Okay. So for now, I'll just leave your answer like that. I'll get back to you. Okay? Any questions regarding that? Is it other than the simplification part? Can I? Okay, let's look at try 8. Okay, we want to look at this curve of this equation. Okay, where A and B are constants, and you're told that it has a gradient of 3 at a point 2, 1. So we want to calculate the value of A and B. Okay, so what will you do to actually solve this question? Put what? Put x together. What do you mean by put x together? Differentiate what? Differentiate x. Differentiate with respect to x. Okay, differentiate this one, dy over dx. Differentiate it, we'll get a plus. Let me just write down. Sorry? What does dy over dx mean? It means differentiate y with respect to x. That's how we covered notation, right? You understand? Okay, so dy over dx is equals to a minus 2b x to the power negative 3. Okay, so since we know that the gradient is 3 at 2, 1, okay, so that means when x is equals to 2, our dy over dx is equals to a minus 2b times 2 to the power negative 3. And then we get a minus b over 4, right? And then since we know that the gradient is equals to 3, so a minus b over 4 is equals to 3. So a equals to 3 plus b over 4. Since we have two unknowns that we are trying to find, we will need how many equations to solve? 2, right? So we have only one equation now. How do we go about finding a second equation to do simultaneous? Huh? Y equals mx plus c?
Sum in y.
Not all tangent, I mean,
Sum in y and x.
Oh,
sorry.
Sum in y and x.
Sub in y and x. Okay, so we are given this coordinate, right? So it will actually fall inside the curve itself. Okay, so we sub in x equals to 2 and y equals to 1 into this equation, right? So we erase this. So similarly at 2, 1, one is equals to a times 2 plus b over 2 squared. Okay, so we have a second equation. So we find that b is equals to -6 and 2/3. Then we can find out what is a as well. Okay, exercise 14.1 will be a long homework, but it is actually short. Okay, so it's really to make sure it's really a long drill. Okay, you have to actually practice on differentiation, because if your differentiation is not done well, then when we go to integration, you will disintegrate before you can integrate. Okay, so exercise 14.1, this one today Thursday. Can I have it on Monday? Hannah? Yes.
When do you use differentiation?
When do we use differentiation? When the question says so long. Yeah. Okay.
When?
Or otherwise, what will you do? What will you do?
If they ask you to factorize x.
Factorize x, put to one side, then so what? So you have nothing. Okay, when you see things that talk about gradient, okay, then it will either be a points line shape kind of question. Okay, remember your gradient perpendicular and then there's diagram and kind. Otherwise, it will actually generally be your differentiation that you have to do.
But if it's a point line shape, then it's this one.
Huh?
It's like points line.
Then the thing is also points line shape, it doesn't give you the equation of the line sometimes. So there's no possibility for you to differentiate, to find the gradient. Okay, so let's move on to 14.2. Okay, 14.2, just now I have actually briefly introduced it when Noel actually proposed a different, an alternative solution. Okay, so the chain rule, okay, basically addresses, right, how do we actually differentiate things like, for example, y equals to x squared plus 1 to the power of 4, right, without expansion. Okay, so this is what chain rule is supposed to address. Okay, because if we were to have y equals to bracket x squared plus 1 to the power of 100, then it will be insane for us to do our expansion. Yes, we know our binomial expansion, but even binomial expansion will need you to expand every single term, okay? Then you can do your differentiation, right? Okay, there's no such thing as differentiation where I need to do ... Okay, no. Right, so it will be ridiculous for us to actually do full expansion. Okay, so the chain rule will address that. Okay, so what the chain rule actually says, I will not put down the actual theory that the textbook has because I think you might not be able to understand it. So basically, okay, if I were to have, for instance, let's just do a bigger number. Okay, y equals to x squared plus 1 to the power of 15. Okay, what we will do is that we will take down the power. So always take down the power, then after that, keep whatever that we have, power minus 1 will become 14. Okay. Then after that, make sure you differentiate whatever that's inside. So technically it is going from outside to inside, okay, with your power rule. You understand what I'm saying? Okay, so differentiating inside itself, x squared when you differentiate will become 2x. Constant number when you differentiate becomes 0. Okay, so for differentiating this, you will get 30x times x squared plus 1 to the power of 14. Keep it compact like that, no need to expand it. Okay, understand? Any questions? So this is basically how chain rule actually works.